In this video we're going to look at Synchromesh manual transmissions. The purpose of a transmission is to turn engine power into vehicle motion, giving us a range of forward gears depending on the opposing forces and desired blah blah blah. Right, in layman's terms, if we didn't have a gearbox, we'd either drive around at 5 miles an hour or wouldn't be able to get up a hill. Basically, the gearbox matches engine speed to road speed. Looking inside the gearbox, we have three important shafts. The first is the primary, also known as input shaft, driven by the engine via the splines in the clutch plate, inputting power into the gearbox. Permanently meshed with this primary shaft by the first constant meshing gears is the lay, also known as countershaft. All the while the primary shaft is turning, its force is transmitted to the lay shaft, and on this lay shaft are a range of gears that are permanently meshed to gears that are supported on, but not splined or connected to, the main shaft. On the main shaft, the synchromesh units are splined to the shaft, and the rest of the constant mesh gears are free to rotate on the shaft with the use of needle roller bearings. A constant mesh gear will only drive when connected to a synchromesh unit, which is in turn splined to the main shaft. In the neutral position, drive comes in on the primary shaft and drops down to the lay shaft through the constant mesh gears. With the lay shaft being driven, all pairs of constant mesh gears are driven but in a freewheeling state on the main shaft due to those needle roller bearings. In first gear, the gearbox gives us the largest gear reduction. When the driver selects first gear, he will move the selector into first gear position, moving the synchromesh, which is splined to the main shaft, into mesh with the main shaft first gear. Drive is now transmitted to the wheels. On acceleration, the engine RPM will rise to the point where you need a higher gear. Luckily for us, the box is full of them. When the driver wants to change up to second, he comes out of first gear and goes through neutral, moving into second gear. The synchromesh unit is moved to neutral and then moved into second gear position, locking the synchro unit to the main shaft second gear, giving us a different ratio due to the higher engine speed. What's that, evil Matt? Why aren't the gears making crunching noises? Well, let me tell you, it's all about the synchromesh. Let's look a bit closer at the gear change. As we can see and hear, it moves across with no hint of grinding. What we have here is first gear, and you can see it's smooth inside and not splined to a shaft. It also has an integral cone, as you can see here. The baulk ring has an internal groove cone, which matches the cone on the gear. When forced together, the frictional properties of the baulk ring force the gear to rotate with it. The inner hub of the synchromesh unit is splined to the main shaft, and the outer sleeve is splined to the inner hub, but allowed to move backwards and forwards over the inner hub. When the baulk ring is placed in the unit, you can see that the outer sleeve will only slide over the top of the baulk ring when the shaft speeds are synchronized, guided by the baulk ring dog teeth. So, if we put it all together, you can see as I put some force against the cone clutch, friction takes over, synchronizing the speeds of the gears. Once the speeds have been matched, further force allows the outer sleeve, via the baulk ring dog teeth, to be guided effortlessly onto the dog teeth of the first main shaft gear, locking it all up as one unit. Ta-da! Let's have a look at that again at normal speed, and then again at super slow-mo. So we can see the inner member, the outer sleeve, the baulk ring, and here the main shaft second gear. As the driver applies pressure to the selector fork, this is a selector fork here, just here, the inner member presses the baulk ring cone up against the cone of the main gear. The baulk ring grabs hold of the main gear and starts to turn at the same speed as they're being pressed together. With further force on the selector fork, and with the speed synchronized, the outer sleeve is guided over the baulk ring and onto the main gear dog teeth. So back to the gearbox. We're still accelerating, and at the top end of second gear, with the engine screaming at us. We need to change up again. When the driver wants to change up to third, he comes out of second gear and goes via neutral into third gear. The synchromesh unit is moved to the neutral, and then the third gear synchromesh is moved into the third gear position, locking the synchro unit to the main shaft third gear, giving us a different ratio due to the higher engine speed. Once again, we're still accelerating and at the top end of third gear with the engine shouting at us. We need to change up again. The driver selects fourth gear, locking the synchro unit to fourth main shaft gear, which also happens to be on the primary shaft. Locking the primary shaft to the main shaft, giving a straight through one-to-one drive with no reduction. Now, sometimes in life, you like to see where you've been and go in reverse. Don't look over your shoulder. Like a pro with a stern look, just use your mirrors. So how do we get reverse out of this gearbox? It's easier than you think. All we need to do is put an idler gear in between the lay shaft and the main shaft to reverse its direction. When the driver selects reverse, he slides an idler gear in between the spur gear on the main shaft and a spur gear on the lay shaft. As they are spur gears, there's no synchromesh unit for reverse, so reverse must be selected when stationary. I'm sure we've all done it while moving and played a nice tune on the gearbox. There we have it. Synchro gearbox in a nutshell. Easy as that. Boom. Thanks for watching.